January 23, 1960. 8:43 in the morning local time. The Western Pacific, roughly 300 kilometers southwest of Guam. Two men are inside a steel sphere less than 2 meters in diameter. The sphere is bolted to the underside of a float tank filled with gasoline, because gasoline is lighter than water and does not compress under pressure. The hatch is sealed. The ballast valves are open. The machine begins to sink. There is no engine, no propulsion. The Trieste descends by becoming heavier than the water around it. Iron pellets held in place by electromagnets serve as ballast. To ascend, the magnets release and the pellets fall away. If the electrical system fails, the magnets lose power and the pellets drop automatically. The machine floats up. This is not a safety feature that was added. It is the entire design philosophy. Auguste Piccard, the physicist who built it, understood something about the deep ocean that most engineers of his time did not. You do not control the ocean. You design a machine that fails upward. Auguste Piccard was not an oceanographer. He was a Swiss physicist who had already set the record for the highest manned balloon flight in 1931. He reached 15,781 meters above sea level in a pressurized gondola of his own design, a steel sphere, sealed, suspended beneath a bag of gas. He looked down and saw the curvature of the Earth. Then he came back and spent the next 2 decades designing the same thing in reverse, a steel sphere, sealed, suspended beneath a tank of lighter-than-water fluid, pointed down instead of up. The geometry was identical. The medium was different. Air thins as you rise, water thickens as you sink. Both will kill you if the sphere fails. By 1953, Auguste and his son Jacques had built the Trieste and tested it in the Mediterranean. By 1958, the United States Navy acquired it for Project Necton, a program to reach the deepest point in the ocean. The Navy wanted the depth record. Auguste was too old to dive. The crew would be Jacques Piccard, who had helped design the vessel and knew every weld, and Lieutenant Don Walsh, a Navy submariner who had never been deeper than a few hundred meters. The two men met weeks before the dive. They had almost nothing in common except the willingness to sit inside a sphere and sink for 5 hours into a place no human had ever been. The descent is what most accounts skip, the fall itself. 5 hours of falling through water that gets colder, darker, and heavier with every minute. For the first several hundred meters, light fades. By 200 meters, the twilight zone. By 1,000 meters, total darkness. The only illumination is the instrument panel inside the sphere and the external light on the Trieste's hull. The light shows nothing. Just water, particulate drifting upward as the vessel sinks through it. Marine snow moving in the wrong direction because the sphere is falling through it. Inside the sphere, the temperature drops. The steel wall conducts the cold of the deep water inward. By 4,000 meters, the air inside is near freezing. The two men wear wool clothing but no thermal protection. There is no heater. The instruments fog. Condensation forms on every metal surface. The air smells of steel, cold, and the faint chemical odor of the carbon dioxide scrubber. They cannot stand. The sphere is too small. They sit on a narrow bench, shoulders almost touching, and watch the depth gauge. The sounds change as they descend. The hull makes noises. Small adjustments as the pressure outside increases and the sphere compresses by fractions of a millimeter. At the surface, the sphere is one shape. At 5,000 meters, it is measurably smaller. Not enough to see, enough to hear. The metal shifts, clicks, groans. Each sound is the sphere negotiating with the water. Neither man had heard these sounds before in testing because the Mediterranean tests had not gone this deep. Every new groan was a new data point. Either the sphere was adjusting normally or it was approaching a limit that no one had calculated precisely. At roughly 9,000 meters, something cracked. The sound was sharp, distinct, not a groan or a shift. A crack. Both men looked at the viewport. The outer window of the observation port had fractured, a spiderweb of lines across the acrylic. The viewport is not a single piece, it is layered. The outer layer had failed. The inner layers held. Walsh and Piccard looked at each other. They had no procedure for this. No one had ever been at this depth. The decision was binary. Stop the descent and release ballast, or continue. They checked the instruments. The integrity of the inner hull appeared stable. No water ingress. The crack had not propagated past the outer layer. They continued. The last 2,000 meters took nearly an hour. The descent rate slowed as the water density increased. The instruments showed depth but not distance to the bottom. They did not know exactly when they would arrive. At 10,916 meters, the Trieste settled into the sediment of the Challenger Deep. A cloud of silt rose around the viewport and blotted out the light. They waited for it to settle. When it did, Piccard saw something through the cracked glass. A flatfish, or something that looked like a flatfish. A pale, elongated shape on the sediment, roughly 30 centimeters long, that moved when the light hit it. He noted it. Some marine biologists later questioned whether a true flatfish could survive at that pressure. The observation has never been conclusively confirmed or denied. The camera on the Trieste's exterior malfunctioned. There are no photographs from the bottom. They stayed for 20 minutes. 20 minutes at the deepest point on Earth. No samples collected, no extended survey. The silt had obscured the camera. The viewport was cracked. The cold inside the sphere was severe. They ate chocolate bars. Piccard noted the depth. Walsh noted the time. They released the iron ballast and the Trieste began to rise. The ascent took 3 hours and 15 minutes. When they surfaced, a Navy ship was waiting. The crew cheered. The newspapers reported it the next day. 15 months later, on April 12, 1961, Yuri Gagarin orbited the Earth. 108 minutes. A single orbit. He saw the planet from outside. He came back to a parade, a title, international fame, and a place in every history textbook printed since. The image of Gagarin in his helmet became one of the most reproduced photographs of the 20th century. Jacques Piccard and Don Walsh received a commendation. The Trieste was eventually retired. The pressure sphere was placed in a museum. Piccard spent the rest of his career designing submersibles that no government fully funded. Walsh became an advocate for ocean exploration and spent decades arguing that the deep sea deserved the same attention as space. He made this argument for over 50 years. He was still making it when James Cameron finally returned to the Challenger Deep in 2012. Cameron brought cameras that worked. The footage showed a barren, flat expanse of sediment. No flatfish. Cameron stayed 3 hours. Between 1960 and 2012, 52 years passed. During those 52 years, 12 people walked on the moon. Hundreds orbited the Earth. 5 robotic rovers explored Mars. 2 spacecraft left the solar system, and no human returned to the deepest point in the ocean. Not because the technology was unavailable, because the funding was. Space had television. It had Cold War stakes. It had a president who promised the moon by the end of a decade and delivered. The ocean had none of that. A descent into darkness does not photograph well. There is no horizon, no curvature, no pale blue dot. There is black water and a steel wall and the sound of the hull adjusting. The visual vocabulary of heroism did not have a frame for 2 men sitting in the dark, eating chocolate, looking at silt through a cracked window. Auguste Piccard designed a machine to go up and then redesigned it to go down. His son rode it to the bottom of the world. The Navy wanted the record. They got it. Then they moved on. The ocean kept its pressure, its silence, and its silt. And for 52 years, the deepest place on Earth sat unvisited, at the end of a journey that takes 5 hours, in a machine that was designed to fail upward, because its creator understood that in the ocean, survival means letting go. Walsh said something once, years later, in an interview that almost nobody watched. He was asked what he remembered most about the bottom of the Mariana Trench. He paused. He did not mention the depth. He did not mention the pressure. He said it was quiet, quieter than anything he had experienced in a submarine. The engines were off. The instruments hummed. And outside the sphere at 11,000 meters, the ocean was still.